So here comes an interesting question, that which NGS platform we should use for our experiments, for our organisms. So that depends upon your biological question, whether you are doing some expression study or whether you are doing to do some genome sequencing project, you are doing some genome assemblies, as well as it also depends upon how much budget you have and what is the expertise of the people who will do the downstream analysis. So it's important that the team you have should know how to handle the data coming out of which sequencers. So for example, if they are good with the downstream analysis of Illumina, you would prefer to do the Illumina sequencing, right? So here we see that there are different, it's a comparative between different sequencing technologies. For the reference, we put Sanger also. That was actually the first sequencing technique, or we can say the first generation sequencing. And we put these next generation or second generation sequencers like 454, Illumina and Solid. And in the next we will also put the third generation sequencers. So if we compare in terms of read lengths, we see that we can have longer reads in Sanger, though the read sizes are smaller here in Illumina, and the smallest in Solid, which is actually 75 base pairs. As far as the accuracy is concerned, everybody claims to be around 100%. Reads per run since Sanger generates just one sequencing reaction, so that is not applicable. But 454 has up to 1 million. Illumina can give you up to 3 billion. So if you are interested in many reads, or you are interested in high coverage of your genome or your transcriptome data, probably Illumina can be a good choice. Solid claims to produce up to a maximum of 1.4 billion reads. How much time they take? Sanger takes like 20 minutes to 3 hours, but obviously it's good for small sequences. 454 goes for like 1 day. Illumina takes 1 to 10 days, but obviously you are getting the high throughput, whereas Solid takes 1 to 2 weeks. As far as the cost is concerned, Sanger, it's around $2,400 per MB. So million base pairs in this much amount of money, so it's expensive. 454 claims to be $10, and Illumina seems like the cheapest, so that is 0.05, just 5 cents to 15 cents, and Solid is 13 cents, so I would say Illumina is cheapest. So if we look into the advantages, Sanger gives you the longer reads, 454 produces longer reads, but so far the technology is not under much development, so it's kind of, losing the market. Illumina produces high yield, so maybe it's good for transcriptome analysis. As far as Solid is concerned, their claims are that their rates are low. Let's look into some drawbacks. For larger sequences, Sanger takes too much of time, so obviously you cannot use that. In 454, since pyrophosphate sequencing is done, there is the problem where if you have homopolymers, so same nucleotide incorporated, over there it has some issues. So since one nucleotide is incorporated and you are getting an electrical signal, but at the same time, if the next nucleotide is the same which is incorporated, how would you distinguish between them? So that is an issue which we call it as a homopolymer errors. Illumina is a little bit expensive. Obviously the machine costs, or if we look down, we would see that its MySeq is $128,000 and HiSeq is $650, so that's too much amount of money. Solid is also slower and the costs are still higher. So instrument cost for Sanger is there was one automated system called as 3730 XL, so that costs like $95,000, which is obviously again high for 454 and Solid machines. So let's see how do these third generation sequencers they fit into this comparison. We already talked about Sanger and Illumina, so Helicose is giving us smaller reads, so 35 base pairs. PassBio, it's really long reads, 3000, and accuracy as per their claims it's 98 to 99%. Reads per run is 1 billion, which is highest in Helicose and PassBios, but so far what we have seen is that these third generation sequencers are still in the process of development. Time per run, if we look into those third generation sequencers, Helicose claims like it can take 8 days and PassBio claims that it can take like 30 minutes. So again, their cost is so far for PySBio is $695,000 which is really high. And for Helicos, we have data which is missing. The cost per MB, if we look into it, Helicos claims like $2, but still it's higher as compared to Illumina. So let's see if those third generation sequencers they come into the market. We expect that they would change the the current trends in sequencing technologies. So far what we have looked into is that different NGS platforms have their own strengths and weaknesses. So which one to choose from depends upon your biological question, depends upon how much money you can afford, and the expertise of your analysts.